We would
Pleasure.
looking into now is some of the basic terms of greenhouse gas inventory, and some of you who are the beginners will certainly benefit from this next like 30 minutes or so, wherein we'll talk about the terms or the concepts that you might encounter when you are working on a greenhouse gas inventory or on a carbon footprint. Now, before we start talking about it, the terms greenhouse gas inventory and carbon footprint are like interchangeably used. They mean the same thing. It actually means, the total emissions of greenhouse gases accounted for a particular organization or an individual or a project for a certain period of time. So greenhouse gas inventory and the carbon footprint are synonymous. One of the most common term that you would also encounter when you're working on a greenhouse gas inventory or a carbon footprint project is an emission factor. Now, it's important to understand that we cannot always, or in most of the cases, you cannot have a direct, measurement or metering of emissions, because a lot of these emissions are point sources. Thousands and millions of vehicles are moving around emitting greenhouse gas emissions. So you cannot have a gas sensor or something placed in all of these vehicles, which aggregates the data, actual emission data. So rather, what people do is they collect activity data. For example, the total fuel consumed, or let's say if you wanted to calculate what's the emission from transportation sector in Dubai, so then maybe what you could do is you could collect the entire amount of gasoline or diesel sold by Enoch and other gas stations, and then probably sum them together and multiply that with an emission factor, come up with a number. So you will be using an emission factor rather than direct measurement, because direct measurement is quite tedious and not practical at all, considering the many number of sources of emissions that we have around us. So that's why we need an emission factor. The emission factor is a value or a factor that would relate the activity data and the quantity of greenhouse gas emissions that comes out of that activity data. By activity data, I mean, for example, consumption of fuel, consumption of electricity, or driving our vehicles. All of these activities that are leading to greenhouse gas emissions. That's why these are called activity data. So emission factors are required, and one of the simplest example is grid emission factor. So when we consume electricity at our homes and offices, the emissions do not happen. We don't see the emissions within our homes or offices, because the emission is actually happening at the power plant where they are consuming the fossil fuel, whether it's oil or gas, and they are generating that electricity. So emissions are happening at the end of power plants, and all of this electricity is then sent to the grid, and from the grid we draw this electricity at our homes and offices. And what several utility companies do is they estimate the quantity of the fuel that they consume within all the power plants they have, and then they calculate the emissions that happen because of that fuel consumption, and then they divide it by the electricity that was exported into the grid. So they come up with a factor which is called grid emission factor, that for a unit of electricity consumption, this is the equivalent amount of greenhouse gas emissions that happened, and that's called grid emission factor. Similarly, there's embodied energy. Embodied energy is a term which you encounter when you are working mostly on product carbon footprint, to understand how much emissions happen because of a production or use of a product. So, for example, if we take any product, for example, our laptops or our mobile phones. So, in manufacturing these phones, a lot of energy goes into it. For example, you extract the minerals from the mines. You bring them to the processing plants. From the processing plants, different metals are manufactured. From those metals are then sent out to the laptop or a mobile manufacturing plant, where they melt and they use it however they want to, and then they ultimately manufacture your product, and they consume all the electricity and fossil fuel in melting and all the manufacturing activities. Then it is again transported back to the consumer, and all in the entire value chain you have a lot of energy consumption. When you sum up all this energy consumption and arrive at a number that this is the energy consumption of a particular product, That's called the embodied energy of that product. Calorific value, you might have heard it a lot of times. It's the energy content of a particular fuel. So it's normally mentioned in joules and calories, and we use it a lot in estimating emissions. And in the, for example, you have to identify a particular fuel that is being used. You need to know the quantity, you need to know the calorific value, because most of the emission factors that you find for fuels are based on the calorific value of the particular fuel. Now, oxidation factor, it's the percentage of carbon which is present in the fuel, and that gets oxidized. So when you combust a fuel in the vehicles or in the power plants or anywhere else, you do not combust 100% of it. Some of it escapes. It could be, and that is called as oxidation factor. So oxidation factor is an important term that is also a concept that is utilized in calculating emissions from different types of fuels. Then biological oxygen demand. This is used to calculate emissions from wastewater treatment. And it is essentially the quantity of oxygen that the microorganisms present in water would need to oxidize the organic content present in that wastewater. For example, the sewage water that is treated at various municipalities, sewage treatment plants, there's a heavy organic load in it. And how much oxygen would be required for all the organic load to be oxidized, and that is called the biological oxygen demand. And it's utilized, like I mentioned earlier, to calculate the methane emissions from the wastewater treatment process, because methane is the main emission that happens from the anaerobic decomposition of organic waste in the wastewater treatment process. Temporary removals and permanent reductions. There are activities that we can undertake that would reduce greenhouse gas emissions, but would that be permanent or would that be a temporary? Based on that concept, these two terms are coined. Temporary removals are those removals wherein we reduce the greenhouse gas emissions, but it is reduced for a certain period of time, and it again goes back into the atmosphere after 10, 20, 30 years. So it's called temporary removal. And permanent reductions are reductions which, when we undertake these reductions, it stays as reduced throughout the lifetime. To give you an example, if we are, let's say, planting a tree, and in 10 years, let's say it absorbs 20 kgs of carbon dioxide. Now, after that, the tree would be harvested and probably would be either used as a fuel somewhere, and if it is used as a fuel, it gets burnt and the CO2 releases back. Or if it's converted into furniture, the furniture is used for 5-10 years, then it's discarded and it again decomposes and CO2 is released back into the atmosphere. So that's kind of a temporary removal. So the CO2 that was absorbed would again be released back into the atmosphere for after 10-20 years. Whereas in permanent reduction, the example could be of solar power generation. So for example, if in an industry there was a diesel-based thermal heater, they were using a heater which was running on diesel. Now they replaced that with a solar heater. So the amount of diesel that they were using earlier would get totally reduced, and that reductions would be permanent. So those kind of reductions would be called permanent reduction. And these concepts are mostly used when we talk about carbon neutrality, or making an industry or an organization or a product carbon neutral. So where we calculate the greenhouse gas emissions for an organization or a product, and then we purchase offsets from the market to say that we have balanced our emissions. And in those scenarios, people look into whether I am buying a permanent carbon credit, or I'm buying a temporary carbon credit. That is when it's mostly used, these two concepts. Baseline emissions and emission reduction. So baseline emissions are the emissions that's happening at an organization, individual, or a product level in a business as usual scenario. So normally people take an average of last 2 years, 3 years, or 1 year, and they estimate the emissions and then set it as a baseline. So anything that would happen in future would always be compared with this duration, and they call it a baseline, like I mentioned. And typically it is done for between 1 to 3 years in order to accommodate for any variation that might happen in a year. And emission reductions, as it says, any reduction of greenhouse gas emissions that we achieve by implementing any measure or a project or any activity that we undertake. So those reductions will be called as emission reductions. Emission neutral. So emission neutral is a term that is used for example, fuels that, for example, biodiesel, where the net greenhouse gas emissions there's no net addition of greenhouse gas emissions into the atmosphere. So what happens in case of biodiesel, for example, biodiesel is made from vegetable oil, and vegetable oil is obviously made from seeds that are from plant origin, and these seeds obviously absorb CO2, and not the seeds, actually the plant, and that manufactures the seeds, and it has carbon sequestered in it, and from that we make vegetable oil that also has carbon sequestered in it. And when we consume and when we combust it in our vehicles or any other equipment that's running on biodiesel, we are releasing the CO2 that was sequestered by the plant. So ultimately it becomes a cycle. So we emit the CO2 from combustion of biodiesel, and it's absorbed again by biodiesel, the plants that would be used for manufacturing biodiesel. So it's kind of a cycle. There is no net addition of CO2 in the atmosphere. The same CO2 is being absorbed by the plant and being emitted. So it's kind of a cyclic process. Whereas if you compare this with usage of fossil fuel, now the petrol, diesel, or other fossil fuels that we are using, in normal scenario would have never come out of the underground reservoirs on its own and would have never got combusted. That carbon would have always been locked inside the ground. So when we combust these fuels, these are net addition to the atmosphere. These were not in the atmospheric circulation. We took it out from the underground and we burnt it to form additional CO2 and added it into the atmosphere. Similarly, Noor gave us an example of HFC and other gases, which have a very high global warming potential. These are not natural gases. These are synthesized gases in our laboratories for different functions. And these did not exist in the atmosphere. So emission of these are again net addition into the atmosphere. So obviously any emission coming out of fossil fuel consumption or any synthesized greenhouse gases cannot be emission neutral. However, if we are using plant-based fuel, and then we can call it emission neutral, because it's a cyclic process. The plants will again absorb it, it will be used as a fuel and be released back. All right, we have a very quick quiz here on the topics that we discussed right now. And let me also look at if we have any questions. Okay, not yet. All right, I guess the questions are visible now. So the first question is on biological oxygen demand. So we just went through some of the concepts, and based on those concepts, we have some questions to refresh what we discussed. So where is BOD required? Why do we need it? In what type of emission estimations? For diesel consumption related emissions, for wastewater treatment related emissions, for transportation or solid waste disposal emissions. The next question is on, all right, yeah. So to calculate emissions from electricity generated on site using a diesel generator, what factor would you need? A grid emission factor, factor for diesel, or emission factor for a specific power plant connected to the grid? When do we need embodied energy? To calculate product carbon footprint, or emissions from electricity use, or emissions for wastewater treatment? And then which of the following is an example of temporary CO2 reductions? solar, biofuel, afforestation, energy efficiency. Afforestation is plantation of trees. Okay, so we'll wait for about a minute for most of the participants to respond to this, and then we'll continue. Meanwhile, if you have any questions, you can shoot it in the chat box in the chat room, and we'll respond to it. All right, let's go through the answers. Okay, there are still some more answers coming in. So, okay, I'll end the poll now and share the results. Okay, so the majority of people have answered the first one correctly. So BOD, or the biological oxygen demand, is the quantity of oxygen that is needed to oxidize the organic load in wastewater. So you need it for wastewater treatment related greenhouse gas emissions. The next one is to calculate emissions from electricity generated on site using a diesel electricity generator. I would require the following emission factors. So majority have got it right. You will need a emission factor for diesel fuel, not for grid emission factor. Grid emission factor is also for electricity, but the electricity that you draw from the grid, for example, DIWA in Dubai. So you need a grid emission factor for that. But if you have your own diesel generator in your industry, then obviously you need to have a diesel emission factor in order to convert the quantity of diesel that you consume into greenhouse gas emissions. Embodied energy, as I mentioned earlier, is used for mostly for product carbon footprint estimations. Most of us have got the fourth one right as well, afforestation. So afforestation, like I mentioned, is forestry or tree plantation, wherein in few years that CO2 would be released back into the atmosphere once that wood is either combusted or degrades on its own. And others like solar, biofuel, or energy efficiency are permanent type of CO2 reductions.